Find the general solution of the differential equation y double prime plus 4y equals 3 cosine t. This is a second order non-homogeneous equation. So to find a solution, we first consider just the homogeneous part, just y double prime plus 4y equals 0, and find the solution of this equation. To find the solution, we find characteristic equation, which is r squared plus 4 equals 0. Solve for r, we get plus minus 2i. Based on these roots, we get cosine 2t and sine 2t as solutions, and their linear combination is the complementary solution. Now we need to find a particular solution. Then ypt is given by, we just replace c1 and c2 by u1 and u2. So u1, unknown function to be determined, u1 cosine 2t plus u2 sine 2t, where u1 and u2 are found by these formulas. Here is u1 and here is u2. Okay, so these u1 and u2 are found using these formulas. So let's go for that. And where u1 is given by, here is the formula, negative g, that's the non-homogeneous term by the way, this is the g part, 3 cosecant, okay, that's the g, times y2 over Wronskian of y1 and y2 dt. So let's find Wronskian of y1 and y2. So we already found y1 and y2 here. This is y1, this is y2. Then the Wronskian of y1 and y2 is, just find the determinant. Y1 is cosine 2t and y2 is sine 2t. In the second row, we just find their derivative. That's negative 2 sine 2t. This is 2 cosine 2t. And to find the determinant, we multiply this minus this. So cosine times 2 cosine 2t is 2 cosine square 2t minus this way, and there is already negative, so this becomes plus 2 sine square t. So 2 sine square 2t, and this is separate by the way. We can factor 2 out, and that leaves cosine square plus sine square, which is 1. So the Wronskian is 2. So Wronskian of y1 and y2 is just 2. So let's find u1, which is now negative g, just the non-homogeneous term, 3 cosecant t times y2 is sine 2t all over, this is 2 dt. Now we need to evaluate this integral. So 3 halves negative, we can pull that outside, and this is double angle formula, sine 2t. Sine 2t is same as 2 sine times cosine, and sine times cosecant is 1. So let me do that. So cosecant is, you can write 1 over sine, and sine 2t is 2 sine t cosine t. Then we can cancel sine and sine, these two also cancel, we can pull outside, and that leaves, we have 2 cancel, so negative 3 antiderivative of cosine, that's the sine t, plus c, we take that 0. So u1 is negative 3 sine t. Okay, now we need to find u2. That will be, go to the top and look at the formula. That will be just without negative, g y1 over Wronskian of y1 y2 dt, which is, this is the non-homogeneous term, 3 cosecant t times y1 is cosine, go up and see cosine here, cosine 2t over Wronskian was found to be 2 dt. Now we need to evaluate this integral. So to evaluate this integral, let's change cosecant into 1 over sine and change cosine 2t in terms of sine as well. 3/2 we can pull outside, that's the constants, and cosecant is 1 over sine t, and cosine 2t is in terms of sine. Cosine is cosecant, sorry, cosine 2t is cosine square minus sine square, or 2 cosine square minus 1, or 1 minus 2 sine square. Since we have sine, so I'm going to go for 1 minus 2 sine square and dt. So we have two terms. Let's separate 1 over sine minus 2 sine square over sine. So 3/2 outside, inside 1 times 1 over sine, that's cosecant, minus 2 sine square over sine, just 2 sine t. Okay, and now we know how to find this integral. This is 3/2. Antiderivative of cosecant is natural log of cosecant minus cotangent, and minus 2 is there. Antiderivative of sine is negative cosine, that makes positive cosine t. Okay, that's the u2 part, u2. Okay, and thus we have a particular solution, which was, if we go up, we had here u1 cosine, u2 sine, and u1 is negative 3 sine. Okay, let me write that. So u1 negative 3 sine t, y1 that's cosine 2t, plus u2, this whole thing we can distribute 3/2. Okay, then 3/2 natural log of cosecant t minus cotangent t, plus 3/2 times 2 cancel, 3 cosine t, that's u2, times y2, which is sine 2t. And this particular solution plus the complementary solution is the general solution. So the solution of the original ODE is YC complementary, that was C1 cosine 2t plus C2 sine 2t. Go up and you can see that, plus YPT. Okay, where YC and YP are given, found above. Okay, final.